Well, hello everybody. Um, so I'm making, when I make these videos, I make them in succession. And so I just finished making one to introduce what a binomial experiment was. And I left it off with, well, how are we going to do calculations that involve binomial experiments? Okay. And that's what this video is about, how to calculate binomial probabilities. But I never know what order people are going to watch the videos, or you may come back to one randomly to look for something. So I like, just in case, I'd start it with the review. And of course, if you don't like the review, you can skip ahead, right? But if we're going to calculate binomial probabilities, then let's start off real quick. What is a binomial experiment? So there's a probability experiment with a fixed definite number of trials, meaning that this is not open-ended. Okay, each trial is independent of the other trials. This means that what happens on one trial in no way can influence or affect the outcome of any other trial. No matter what the nature of the experiment is, there's only two mutually exclusive outcomes, success and failure. By mutually exclusive, I mean that they can't both happen. And again, like a real basic example of a binomial experiment is a coin flip, flipping a coin a certain number of times. There's only two outcomes, heads or tails. They can't both happen. Each flip is independent of all the other flips. They cannot influence each other, and so on. And then the probability of success, whatever you deem success to be, however you label it, is the same for each trial. So like as you flip a coin repeatedly, the odds of getting a heads, for example, or a tails, whatever, does not change as you continue to flip the coin. Okay, and the random variable x will count the total number of successes out of the whatever the fixed definite number of trials is. Now, real quick, remember, n is our symbol for the total number of trials. P is the probability of success on any trial, however, whatever success is determined to be. Q is the probability of failure on any trial, and Q will be 1 take away P every single time. And X is the random variable that counts the number of successes. Okay, now, here's how you do the calculations. I mean, it looks intimidating if I write the formula out, and that's true for a lot of mathematical formulas, at least to some people. Math looks intimidating when you start writing out formulas and you see letters all over the place, but we'll talk about different ways you can do this, okay? So let's start with this is the kind of thing that we want to do. Suppose you have a binomial experiment, and I want to calculate the probability of exactly x successes out of the n total trials. The way you do that is with this formula, which can be expressed in two different ways. Let me read the symbols to you, and I'll tell you a little bit about different ways we can do this, okay? That says n factorial. So this is an exclamation mark. I know that, but in math, it's called a factorial. So the probability of x successes in a binomial experiment out of n total trials is n factorial divided by n take away x factorial times x factorial times p, the probability of success on any trial, to the x power, times q, the probability of failure on any trial, to the n take away x power. Okay? Now the formula is more complicated than I'm going to explain in this video, but you can look at it like this. You see why that's p to the x power? Well, x is how many successes there are. So maybe it kind of makes sense that you take p, the probability of success, to the x power, how many successes you want to calculate the total probability of. And what would n minus x be? Well, there are n total trials, and x is the number of successes out of the n total trials. So n minus x is the number of failures out of n trials. So then that's why there's this factor q, the probability of failure on any trial, to the power n minus x. Okay, so that's one way that you can do this. Now, doing it with that formula would, for most human beings, require a handheld calculator. This factorial function right there, the exclamation mark, That is one of the included functions on a scientific calculator. Here's my calculator. It's on my calculator. Okay. Another thing I could do is this will get you exactly the same number. This is called n choose x. It's also called a combination. It's another function that your calculator would have. I can't really give a complete tutorial on using a calculator because the menus in everyone's calculators are slightly different, and how it would look on mine is a little bit different than how it might look on somebody who has a different calculator. But my point is, both the factorial function, if you want to do it this way, or the combination function, it'll look just like that in the menu. It'll be a subscript number and a capital C, and then another subscript number. That's also in one of the menus in your calculator. So we do that, okay, times p to the x power times q to the n minus x. Okay, so those are the formulas as they are on paper, where you might be really intimidated now and like thinking, how am I going to do that? But let me encourage you to try, if you have a handheld calculator, to use the formula, all right? So here's an example that we'll go through real quick. Suppose that a survey has found 52% of adults in the United States have very little confidence in any kind of news or journalism. You just don't trust it, okay? Let's say. And suppose we randomly select 10 U.S. adults. Okay, maybe you see where this is going about why it's a binomial experiment. So we could say, okay, of those 10, we could go through them one at a time and say, do you have very little confidence in any kind of news or journalism or not? Okay, it's either you have very little confidence in any kind of news or journalism, or you feel some other way, okay? Now, suppose we randomly select 10 people, right? Calculate the probability that exactly 5 of these 10 will have very little confidence in any kind of news or journalism. So that's a binomial experiment as you select those 10 people and go through them one at a time to see whether they feel that way or not. So it's a binomial experiment. We might say n will be 10 trials, and I'll define success as the person that you ask at the moment saying they have very little confidence in any kind of news. Okay, what's the probability of a success? Well, if 52% of adults feel that way, then I would say for any one randomly chosen person, there's a 52% chance they feel that way. And so probability of success is 0.52. What's the probability of failure? The probability that they don't feel that way, that they feel some other way. That could be, well, I have to do 1 take away 0.52, which is 0.48. And then x will be 5. Because the question is, calculate the probability that 5 of the 10 who are randomly selected will have very little confidence in any kind of news. So it's like saying, what's the probability of 5 successes? Okay. Now, here's the result of that formula both ways. Okay. Probably 5 successes out of 10 trials. All right. Look at this. I copied it down. These are the numbers. All right. Okay. 52% chance of success, 48% chance of failure. 10 factorial, 10 minus 5 factorial times 5 factorial. So I broke it all down. I did all the calculations though here, okay? Like 10 factorial I did in my calculator. 5 times 5 factorial, also in the calculator. Multiplying it all together, but I get 0.24, okay? Now I'm going to encourage you to try with your calculator so that you'll know how to do that if it comes to it, right? That you'll know that when you see that formula, it can all be done in here. I just have to use the factorial function. Okay, all right. Now, okay, so that means that, well, okay, if with the United States population being what it is and 52% of people feeling this way, if I select like 10 at random, the odds that 5 out of the 10 will have very little confidence in any kind of news or journalism, it'd be about a 24% chance. The number I got was 0.24 as a probability of that. Translates to 24% chance. Okay. All right. Now, I did want to have like just a slide that called out all of the symbols in those formulas and what their names are, okay? And even though I already said it, to emphasize that they can be done in this, a scientific calculator. So this is called a factorial, n factorial. That's what like 10 factorial is, or 5 factorial, and so on. It's in your calculator. And this is called a combination, all right? N choose x. Both of those are in there, okay? But they both be found in a scientific calculator. And you can use this formula either way. In the example I just showed you, I only used this version of it. I didn't try this one, okay? Now, let's look at one more example, and then we are going to have to find an easier way to do this. I think everybody should know how to do things the most basic way. I'm not saying you have to do it that way, but I'm saying you should know, okay? So I'm going to do this one, all right, in the most basic way with my handheld calculator, and then we'll find something easier, all right? Well, you say, why do I do that? Well, it's just I think if you're in school, you should learn things. You should learn everything, okay? Like you should know how to do anything that comes your way, whether it's some math with paper and pencil and a basic calculator, or using Excel or some kind of software or whatever it is. I think you should just learn all of it, okay? So that way you're prepared for anything. Okay, so let's look at the same example again, but a slightly different question. Suppose that there's that same survey found that 52% of adults have very little confidence in any kind of news or journalism. Now, again, we're going to randomly select a group of 10, and every one of those individual 10 people either feel that way, that they have very little confidence in any kind of news, or they feel some other way, okay? What's the probability that less than 4 of the 10 will have very little confidence in any kind of news or journalism? Okay, well, so remember the other question said, what's the probability that exactly 5 out of the 10? And then this one says the probability that less than 4 out of the 10. Well, what would that mean? The probability that I take 10 and less than 4 have very little confidence in any kind of news. Well, that could be like, I guess they could have in different ways. Like, that could be that none of them felt that way, or one of them felt that way, or 2 of them felt that way, or 3 of them felt that way. Isn't that like every way that we can encompass the event that less than 4 of the 10 have very little confidence in any kind of news? Yeah, it could be 0. I mean, that would qualify. Could be 1, could be 2, could be 3 out of 10, whatever. Now, the thing with this is those are mutually exclusive events. And one thing that I covered when we were learning about probability calculations is the addition rule. If the probability of like event A or B, if they are mutually exclusive, what's mutually exclusive mean? They can't both happen at the same time. So none of these can both happen at the same time. You know, having 0 out of the 10 be the result, or 1 out of the 10 being the result. Those can't both happen at the same time, all right? Okay, now, so because of that, we use the addition rule, which means that the probability of 0 or 1 or 2 or 3 is the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. And that would encompass the whole thing. Less than 4 means 0, 1, 2, or 3. And because they're mutually exclusive, that's the probability of each of those individually added together. All right, now what you see here is that formula that I could scroll up. It's this version of it though, okay? The probability of X successes of N trials is N CX, sometimes read N choose X, P to the X power Q to the N minus X. So when I do the probability of 0 out of the 10 people feeling that way, that would be 10 choose 0. 0.52 to the 0 power, 0.48 to the 10th power, plus 10 choose 1, the probability of 1 out of the 10 people having very little confidence in any kind of news, times 0.52 to the first power, 0.48 to the 9th power. Anyway, so then there's the rest of them. Now what that works out to be this is a lot of math to do on a handheld calculator. Let me tell you. But as it is, I did all these individually and I added the 4 results together. I got 0.141. So that's like a 14% chance, okay, that you select 10 and less than 4 of them will have very little confidence in any kind of news or journalism. Okay, so that's hard to do, but that's the formula. Somebody may give you that formula and expect you to know it. If you're using my math lab, it may come up. The help feature may give it to you and tell you to do it that way. Everybody should see it as part of the class, okay? It's not easy, though. It's not easy to do things that way. As it says here, that's a lot to do with only a handheld calculator. Is there an easier way? Can we use StatCrunch? Can we use Excel? Okay, so yeah, let me show you how to do that. Let me show you how to use StatCrunch. I want to do this same question with StatCrunch, okay? Now, so let's do this. Like, say, here's how you might have access to this. Like, I just have the homework open. This is no particular question, but if I go to get more help, I can open StatCrunch. Okay? And here we are in StatCrunch. Now, suppose that I have this binomial experiment. Oops. Let's go back to this. And I'm going to have 10 trials, and there's a 52% chance of success on any one trial. And I want to find the probability that less than 4 successes, okay, basically. Then, well, let's see. Okay, so let me open StatCrunch again. So here it is. What we do is we go to Stat and Calculators and Binomial, okay? And then it opens this. Now, you have to fill in all the specifications for this, okay? Like, N is how many trials there were. So 10 is the default, so I don't have to change that. The probability of a success, like as you go through those 10 people and you say, do you have a little confidence in the news or not? The probability was 0.52 that they felt that way, and that's what we deemed a success. And here's the probability part of it. We want to calculate that one question I was just showing you was the probability of less than 4 successes, okay? So the probability that X, the random variable, is less than 4. See how I put that in and compute? See that number is 0.141. That is, okay, where am I going to find my, okay. That's what I got, 0.141. I did it by hand. It was really hard to do. I got the same number, okay? So yeah, I mean, you're going to most, if not almost all the time, use StatCrunch to do the binomial probability calculations. But I have the whole story in the video, okay? I could have elaborated a little bit more about how you do these calculations on paper. I guess I could get like a bunch of different kind of calculators and show you how to do it that way, but let's do this. We have StatCrunch. You're using my math lab anyway. It's right there, all the binomial calculations you need. And maybe just expect as you go through the homework to do them that way unless something came up to prevent it.